What if the universe you believe in, perfect, balanced, predictable, was lying to you? What if every law you trusted, every rule written into the fabric of existence could be broken? Because once upon a time, one woman did just that. Her name was Chien-Shiung Wu, and her discovery didn't just change physics. It shattered our understanding of reality itself. Before we step into her story, before we see how one quiet, brilliant woman rewrote the laws of the universe, make sure you stay until the very end. Because this isn't just a story about science, it's about symmetry, injustice, and brilliance. And how sometimes, even when the universe itself isn't fair, truth still finds a way to shine through. In the early 1950s, science believed in symmetry, not the beauty of shapes, but the balance of nature. Every particle in the universe, it was said, had a mirrored twin. If the laws of physics applied to matter, they had to apply to its reflection. This belief, called the law of parity, was sacred. It was elegance. It was order. It was the universe saying, I am balanced. But soon, that illusion of perfection would crack. And the person holding the hammer was a woman the world didn't expect to matter. Chien-Shiung Wu was born in 1912 in a small town in China, where the idea of a girl becoming a scientist was almost laughable. Her father, however, was no ordinary man. Her father often told her, "There is no law that says girls cannot become scientists." That sentence became the nucleus of her life, a spark that would one day ignite one of the most profound scientific revelations in history. In 1936, with 2 suitcases and a dream, Chien-Shiung Wu boarded a steamship bound for the United States. She was 24. The world around her was shifting, caught in the tension of approaching war. But Wu had one goal: to understand the universe. At the University of California, Berkeley, she stepped into one of the world's most advanced physics laboratories, a place dominated by men and governed by brilliance. Yet, she didn't just fit in, she stood out. Her intellect, her precision, her tireless dedication soon caught the attention of physicist Ernest Lawrence, the Nobel laureate who had built the first cyclotron. Wu worked long nights, surrounded by the hum of machines and the glow of radioactive materials. Her colleagues called her the Chinese Madame Curie, though she never sought comparisons. She wasn't chasing fame, she was chasing truth. During World War II, Wu was recruited into the Manhattan Project, helping refine uranium for the atomic bomb. It was the pinnacle of human achievement and human destruction. She played her part in a world-altering project, yet deep down, she was uneasy. Science, she believed, was meant to illuminate, not annihilate. And so, when the war ended, she turned away from weapons and returned to pure research, determined to uncover the mysteries of nature, not its capacity for chaos. By 1956, the world believed physics had reached perfection. Every theory was neat, every law symmetrical. Then, 2 young theoretical physicists, Sung Li and Chun Yang, approached Wu with a dangerous question. What if the universe wasn't symmetrical? What if, under certain conditions, nature didn't mirror itself? Their idea was heretical. It challenged everything scientists thought they knew about reality. But when others dismissed the idea, Wu didn't. She listened. She studied their equations. Then she said calmly, "We can test it. But it won't be easy." That single statement would redefine physics forever. In a cold laboratory at Columbia University, Wu began the impossible. She used cobalt-60 atoms cooled to nearly absolute zero and placed them under a strong magnetic field. If parity, the belief in perfect symmetry, was true, the particles would behave the same in both directions. But if it wasn't, if the universe really did have a preference, her instruments would show it. Night after night, Wu worked with unwavering precision. Her hands, often numb from the cold, adjusted dials and read meters as frost gathered on the walls. She barely slept. For weeks, the hum of the machinery became her heartbeat, the rhythm of discovery pulsing through the silence. She didn't just conduct an experiment, she orchestrated it like a symphony, balancing precision with intuition. And then, one night, the readings came in. The results were undeniable. The particles didn't behave symmetrically. They decayed preferentially in one direction, violating the law of parity. The universe wasn't balanced. Nature had a bias. Symmetry, one of science's most sacred assumptions, was an illusion. When news of Wu's discovery spread, it sent shockwaves through the scientific world. Physicists were stunned. The elegant, orderly image of the universe had been torn apart by a quiet woman working through the night in a cold lab. The law of parity, a cornerstone of modern physics, was gone. In its place stood something far more chaotic and infinitely more real. But when the 1957 Nobel Prize in Physics was announced, it was awarded to Li and Yang, the theorists who proposed the idea. Wu, the experimentalist who proved it, was left out. Her name was whispered in labs, but absent from headlines. Her data had made the impossible possible, yet her recognition was stolen by the very symmetry the universe had already denied. She didn't rage, she didn't demand acknowledgement. When asked about the oversight years later, Wu said quietly, "I have done the work, and it is good." It was not resignation. It was strength, the kind of strength born from truth. Because even in a universe that isn't symmetrical, integrity remains unbroken. Chien-Shiung Wu became a living paradox, a woman who revealed the universe's imbalance, yet lived in a world that mirrored that very injustice. She was proof that even when the system is flawed, brilliance cannot be silenced. When the world woke up to Chien-Shiung Wu's discovery, physics as a field entered an identity crisis. Everything that scientists had taken for granted, every symmetry, every reflection, every so-called perfect balance, had been violated. It was as if the universe itself had blinked, revealing its imperfection, and that blink was caught forever in Wu's data. Her experiment was so groundbreaking that it reshaped quantum theory, changed nuclear physics, and sent ripples through cosmology. Yet, while theories and equations were rewritten, one truth remained constant. The woman who had made it all possible stood quietly in the shadows, watching her discovery become the foundation of others' fame. In the halls of Columbia University, colleagues whispered her name with reverence. Students who passed by her lab could still see her working into the night, surrounded by rows of instruments and flickering monitors. Wu wasn't one to celebrate. She was one to refine. She continued testing, measuring, perfecting. Every result she achieved was not just an answer, but a challenge to dig deeper. Her mind was a map of the invisible, tracing the forces and asymmetries that governed reality itself. But while the scientific world marveled at her precision, the social world refused to move. The Nobel Prize had gone to Li and Yang. Newspapers printed their portraits, not hers. Headlines called them the men who disproved symmetry. Wu's name was footnoted. A quiet acknowledgement buried under the glamour of male recognition. Yet, even through that injustice, Wu didn't falter. "The laws of nature," she once said, "are not dictated by human prejudice." That quote was more than a statement. It was a rebellion. She knew the irony too well. She had proven that the universe itself didn't treat every direction equally. Yet humanity still insisted on bias. For Wu, symmetry had broken twice, first in physics, then in life. Her colleagues often recalled that she carried herself with a calm that could silence a room. Her eyes held both intellect and distance, as if she was always calculating something greater, something unseen. And she was. Because even after the parity violation, Wu was not done transforming science. Her curiosity was insatiable. She began to turn her focus toward beta decay, the process by which unstable atomic nuclei release energy and transform into something new. It was poetic, really. like atoms shedding imbalance to find stability. She, too, was working to find equilibrium in a world that refused to give her credit. By the 1960s, Wu was already a legend in the corridors of physics, even if history refused to say her name out loud. She became known as the First Lady of Physics. To her students, she was a force of nature, demanding, brilliant, precise. In her lectures, she spoke softly, but with such clarity that even the most abstract theories became tangible. Her hands would move through the air as she explained the invisible dance of particles, as if she could see what others couldn't. One of her students once recalled a moment during a lecture when Wu paused, looked up from her notes, and said, "The universe may not be symmetrical, but it is still beautiful." Because imperfection, she smiled faintly, is what makes it interesting. That sentence lingered like a revelation. It wasn't just physics, it was philosophy. She wasn't merely teaching about forces and fields. She was showing her students how to embrace the imbalance that defines existence. But even as she shaped generations of scientists, Wu couldn't escape the weight of recognition denied. The 1957 Nobel Prize had cemented an unfair truth. The world was ready to accept her ideas, but not her. She didn't protest publicly, but privately, her disappointment was known. Her husband, physicist Liu Yuan, often told friends that Wu felt a kind of quiet pain. "She knows she changed the world," he once said, "but the world has not changed for her." Still, Wu pushed forward. She became one of the first women ever to hold a tenured position at Columbia University, and she used her platform not for self-praise, but to lift others. She began mentoring young women in physics, telling them, "Do not let your gender define your path. Let your curiosity do that." When the U.S. government began to honor scientists who had contributed to national progress, Wu was invited to the White House. There she received the National Medal of Science from President Gerald Ford in 1975, standing in that ornate room. Under chandeliers and flashes of cameras, she smiled politely, but those who knew her say she still carried that quiet dignity, as though she was accepting not just for herself, but for every woman who had been erased by history. And indeed, she was. But Wu's influence stretched even further, across borders and generations. In her homeland of China, she became a symbol of possibility. Her story began to circulate in schools, inspiring young scientists who had never seen a woman in the pages of science history before. For them, she was proof that brilliance knows no nationality, no gender, no barrier. Meanwhile, her work continued to ripple through physics. The discovery of parity violation didn't just rewrite one equation, it reshaped the way we see the universe. It revealed that certain forces, particularly the weak nuclear force, operate asymmetrically. That insight became the seed for future discoveries, including the understanding of why matter dominates over antimatter, why the universe even exists in the first place. Without Wu's experiment, the very fabric of cosmic evolution might still be misunderstood. And yet, for decades, she was absent from textbooks. When mentioned, her name appeared in parentheses, as though her contribution was a footnote in someone else's story. But time has a way of correcting imbalance, even the kind created by humans. In the late 20th century, as the world began to reckon with the erasure of women from history, Chien-Shiung Wu's name began to re-emerge, not as a side note, but as a headline. The American Physical Society called her experiment one of the most elegant in modern physics. Universities began to honor her legacy. In 1990, a building at Columbia University was renamed in her honor. And gradually, her story became a symbol, not of loss, but of triumph. Because the truth is, Wu never truly lost. Her discovery still shapes everything we know about physics today. Her data is still cited. Her experiment is still taught. And her courage, the quiet defiance that led her to question the universe's symmetry, remains one of the boldest acts in scientific history. But behind all of that brilliance was a woman who simply loved science. She didn't seek glory, she sought understanding. When asked later in life what drove her, she replied, "I have always believed that science is a kind of worship, not of gods, but of truth." Those words reveal who Wu really was, not just a physicist, but a philosopher of reality. She didn't chase balance. She chased meaning. As the years passed, the world of physics continued to evolve. But the echo of Chien-Shiung Wu's discovery lingered, a reminder that even the smallest imbalance in nature could birth an entirely new understanding of existence. By the late 1970s, Wu had become a living legend, though she carried her fame like a burden rather than a crown. When she lectured, her tone was calm, her movements precise, and her logic flawless. Students described her as intimidating, not because she demanded respect, but because she embodied it. She had proven the impossible, yet remained profoundly human. A woman who had glimpsed the flaws in the universe and still found it beautiful. Wu often said, "Science is not a solitary pursuit. Every discovery is a step built upon countless others." That humility defined her life. She never claimed to have single-handedly changed physics, even though she had. She credited her mentors, her colleagues, her students, anyone who had shared the pursuit of truth. But deep inside, those close to her knew she carried a quiet ache. Recognition had come too late, and often too little. She saw her male counterparts celebrated endlessly, while her own contributions were simplified into a sentence. Wu confirmed the theory, and yet she never grew bitter. Instead, she turned that silence into mentorship. She believed that if she couldn't rewrite her own recognition, she could rewrite the future of others. She devoted her later years to advocating for women in science, urging universities to hire and promote based on brilliance, not bias. At every conference, every ceremony, she became the voice of quiet rebellion, the proof that even unacknowledged light still shines. In one interview, when asked how she endured being overlooked, she smiled and said, "There is only one thing worse than being forgotten, and that is forgetting why you began." Those words, spoken softly, carried the weight of a lifetime. In 1978, she became the first living scientist to have an asteroid named after her. 2752, Wu Chien-Shiung. A poetic tribute to a woman who had spent her life studying the invisible forces that shaped the cosmos. Somewhere, far beyond the reach of human eyes, a silent rock now carries her name through the cold infinity of space. A symbol of immortality earned not through fame, but through discovery. Her later experiments, while less publicized, continued to refine the world's understanding of radioactive decay and nuclear structure. Even as her health began to decline, she never abandoned her laboratory. Colleagues would find her working quietly at her desk, notes meticulously arranged, data charts annotated with the same elegant handwriting she had used for decades. She once told a student, "The moment I stop asking questions, I will stop existing." And when that moment finally came in 1997, it wasn't the end. It was the continuation of everything she had stood for. Her ashes were returned to her birthplace in China, buried beneath the same sky she had once gazed upon as a child, wondering how the stars shone. A small monument stands there now, simple, graceful, inscribed with her name and one line: "The woman who changed our understanding of the universe." But perhaps the most beautiful part of her legacy is not in stone or metal, but in the countless young scientists, especially women, who saw in her a reflection of possibility. Her story became a spark. It told the world that intellect knows no gender, that brilliance does not need permission, and that truth, once discovered, can never truly be silenced. Today, her discovery remains one of the cornerstones of modern physics. Every time a student learns about parity violation, every time an equation assumes asymmetry, Chien-Shiung Wu lives again, not in the footnotes, but in the very structure of knowledge. The universe may not be symmetrical, but history has a strange way of balancing itself, slowly, quietly, inevitably. And perhaps that is the most poetic truth of all. The woman who proved that nature itself breaks symmetry became the force that restored balance to science. Before we close her story, let's pause for a moment. Look at your surroundings, your phone, your computer, the technology that connects us right now. Behind every device, every experiment, every theory, lies the work of someone who dared to question what everyone else accepted. Chien-Shiung Wu did not just rewrite physics. She rewrote the limits of courage. And that's what Pioneers in the Dark is all about, uncovering the brilliance that the world tried to forget. So if you felt inspired by Wu's story, by her relentless pursuit of truth in a universe that refused to play fair, then don't let her fade again. Hit subscribe, because next time we'll dive into another forgotten mind who shaped reality as we know it. Because the light of discovery doesn't always shine in the open. Sometimes it begins in the dark.